Today we're going to be looking at graphing of quadratic functions. Using f of x equals x squared minus 3x minus 4, we asked to find the vertex and any intercepts. So we go ahead and factor that, and it factors quite nicely into x plus 1 times x minus 4. So the intercepts then are at negative 1, 0 from this, and 4, 0 from this. So the vertex is halfway between those, so the value for the vertex is negative 1 plus 4 divided by 2, which is 1.5. Plugging that 1.5 into the original equation to find y, we have 1.5 squared minus 3 times 1.5 minus 4, and when we do the math, we end up getting a negative 6.25. So the vertex is at the point 1.5 minus 6.25. Using the vertex formula, we have a negative b divided by 2a, and then we evaluate the original function at that negative b divided by 2a. So first, find the vertex of this. We are doing it with the vertex formula, which is a negative 3 divided by 2 times 1, which we find that is 1.5. Putting that 1.5 into the original equation, we find that our y value is a negative 6.25. Then once again, our vertex is at 1.5, negative 6.25, using the vertex formula. We're asked to graph that function, x squared minus 3x minus 4. Well, we figured that out, that the intercepts are at negative 1, 0, which is right here, and 4, 0, which is right here. The vertex is at a 1.5, a negative 6.25, which is right here. So that is the graph of our x squared minus 3x minus 4. We're asked to find the vertex and any intercepts of 2x squared plus 4x plus 1. So we have a negative 4 divided by 2 times 2, which is simply a negative 1. Plugging a negative 1 into our original equation, we find that the y value is also negative 1. So the vertex is at the point negative 1, negative 1. Letting x be 0, f at 0 ends up being 1 when we plug it into the original equation. So the y-intercept then is at 0, 1. Graphing those points then, we have the vertex at a negative 1, and the y-intercept at 0, 1, and that's our nice quadratic function. Find the vertex and any intercepts of a negative x squared minus x plus 2. Using our vertex formula, we find the x value is a negative 1/2. Plugging that negative 1/2 into the original equation, we find our y value to be 2 1/4. So that is the vertex, negative 1/2, 2 1/4. Factoring out a negative, so we can go ahead and factor this quadratic. It factors quite nicely into x minus 1 times x plus 2. Again, we have that negative out front. So the x-intercepts then are at negative 2, 0, and 1, 0 from setting each of these pieces equal to 0. And then we have f at 0 being 2. So we find the y-intercept to be 0, 2. Graphing that function then, the vertex is here at a negative 1/2, 2 1/4, and the x-intercepts are at negative 2, 0, and 1, 0, and the y-intercept then is at here, 0, 2. It is upside down because we factored that negative out. Remember, that's a negative x squared, which flips the quadratic downward. Finding the minimum and maximum, the quadratic that opens upward has a minimum, and the quadratic that opens downward has a maximum. Our previous problems opened downward, and its vertex is at negative 1/2, 2 1/4. So that is the maximum. We have a nice little problem about a water fountain. It has water that is in the shape of a quadratic function. Its height in inches above after m seconds is given by the function f at m equals a negative 16m squared plus 10m. We're asked to find the maximum height of the water as well as the number of seconds it took for the water to reach that maximum height. Pardon me. So we have a negative b over 2a, and we find that that's 5/16, which is our x value of our vertex. Plugging that in the original equation to find the y value, we find that that's 25/16. So the vertex then is at 5/16 for x value, and our y value is 25/16. So the maximum height then is 25 over 16 feet, which was reached in 5/16 of a second.